pick up and take home with you if you'd like. They're right here, all in this corner right here. So, a little bit about my background, not that it's that critical, but I'm a kind of a technical kind of guy, but this is not a technical talk. But just so you know, from my background, I was the engineering director, operations director, and plant manager at the Comanche Peak nuclear plant. I built and put 3 nuclear plants into service. I was a Navy nuclear submarine officer, so I'm kind of one of those guys that likes to know how things work. But the good news is, you don't need to be an engineer to understand all of this and just get a bit of understanding about solar. But it's a little more technical than just turning on a light bulb. And so what my intention here is to kind of give you a little bit of basic information if you're considering solar. And then my experience now, having gone about 15, 16 months with solar panels installed, my experience on that. And then if you're thinking about it, what are the costs and those things that you need to be thinking about? So that's what we're going to try to accomplish. If there's anything that you see up there, information you'd like to capture on your phone, feel free to do that. Just take a picture of the slides. Okay. So first of all, question is why go solar? Well, there's a lot of different reasons for it. One is reduce your electricity bills, and that's pretty straightforward. Reduce your carbon footprint. And I'll tell you right up front, this is the main reason why I installed solar system at my house, because I was concerned about that. You may have an electric vehicle, which I have. And if you've got solar panels, you can use the EV, you can use them to charge your electric vehicle. Protect from grid outages. And they do happen from time to time. Those of you who remember Snowmageddon, I had power loss for 4 days in my house. This was before I had the solar panels installed. Broke 2 water pipes and was not a fun experience. And also, if you're making more than you're using, it's possible, if you got it set up right, that you can sell your excess generation another way to help reduce your costs. And then finally, you may be interested in just going totally off grid, which is very challenging, I'll tell you right up front, but it is possible. So the main thing that's important here is there's hardware differences depending on what your objectives are. And that's one of the things I hope to cover here. So that's important before you get started, is you got to ask yourself, what is it I'm trying to accomplish? And we're going to cover these various options. So our outline then is we're going to talk about various components so you get familiar with the terminology, the different options, and system configurations depending on what your objective is. Talk about my real world experience, how to size your system, and what you should expect cost-wise. So first of all, some terminology, and learn about these components. Well, there's your meter, and it's not the meters of the old. Remember, years ago, they had little dials on them, and guys usually had to come by once a month and read them. And that's how your bill was calculated, depending on the difference between last month's and this month's meter reading. Well, they're not like that anymore. They're digital. And nobody comes around and reads them anymore because Encore can read them remotely. So this is what your meter looks like now. The thing to keep in mind while we're talking about solar systems is this meter only sees what passes through it. Power you pull off the grid or excess generation you send out to the grid. It doesn't see what goes on behind the scenes with your solar panel and in your house. Only it's just a point, and it just sees what comes and goes. So that's our meter. Then watts, kilowatts, and megawatts. I tend to throw these terms around because, you know, as an engineer, a watt is just a measure of power. And if you got 1 volt and 1 amp, that's 1 watt. You can think about a 60-watt light bulb. You got it plugged into your wall, 120 volts, that draws a 0.5 amp. Okay. 1,000 watts is a kilowatt and 1,000 kilowatts is a megawatt. So we typically talk in terms of watts on loads, kilowatts in terms of your usage, and megawatts if you're in your generation business. Comanche Peak Nuclear Power Plant generates 2,400 megawatts, okay, or 2.4 gigawatts. And then you carry that wattage over an hour. Say you're drawing 100 watts, like a light bulb, and you go for an hour, you just used 100 watt hours. Or if you run your microwave, if you could run your microwave for an hour, and let's say it's 1,000 watts or 1 kilowatt, you run it for 1 hour, that's 1 kilowatt hour. That's a convenient number that Encore uses in your electricity provider for determining your electric bill. Term PV is short for photovoltaics. Inverter. Inverter is a device that just takes DC input, like off a battery, and makes AC out of it. And so instead of just being a DC, solid DC power plus and minus, it gives you that sine wave, 60 cycles per second. And last thing on this slide, MPPT is a term you might hear, maximum power point tracking or controller. You got to remember your solar panels are making DC, gang together somewhere around 500 volts. Somehow they got to make AC, and somehow they got to get that in sync with what's coming in off the grid. And that's what that does. All these are always in the black box somewhere, but that's what that device does. So let's talk about the grid. That in the state of Texas mostly have put infinite supply of electricity. And it comes from, there's three elements associated with the grid. One is the distribution system, which is Encore, the power lines, the ones that control your meter, the generating stations, like Wolf Hollow, Comanche Peak, and all the other power plants, and then your retail electric provider. And that's the person you buy your electricity from. They typically have nothing more than a computer. They buy power on the wholesale market and sell it to you in the retail market. They don't own power plants. They don't own the transmission lines. So, question for you. If you're not in a co-op or a municipal power supply, then you have the option of picking your retail provider. So, and I'm not sure where you stand, but if you're like in the city of Granbury or with some co-op, you may not get this choice. You're gonna be with that particular retail provider, and that's important. Okay, so now we're going to talk about those solar cells. So, little solar cells about this big, and they're getting together on a panel. My panels are just a little bit more than 7 feet tall, about 3.5 feet wide. And then you can gang those together to up the voltage. So one of these panels here may be generating 50 volts, and you gang several of them together, maybe up as high as 500 volts by the time it comes out. So these photovoltaic cells convert sun energy into electrical energy. And it's very, we're not going to get into quantum mechanics, how that works, but so it's just kind of magic, okay? Sunlight, and it makes it like a little battery cell. So what you have here is like a little miniature battery, a whole bunch of them gang together here, 48, 50 volts, and then gang them together and get them up to like 500 volts. So it's taking the sun's energy, which is a little under 1,000 watts per square meter at the surface in the middle of the afternoon, right? Highest. And they're about 15 to 20% efficient in terms of being able to convert that sunlight to electrical energy. One of my panels produces 435 watts. I have 40 of them for a grand total of just under 18 kW solar panels. And that's a lot, probably more than you need. We'll talk about that in a little bit. So, working our way through the components. This is the black box that really controls the whole thing. It's got the inverter in it. It's got those MPPT controllers, all the inputs here from the solar panels. You can connect it to a generator. It hooks to the house. This is the brains of the system right here. So that's what takes that that voltage from those solar cells makes the AC and ties it into your electrical system in sync with what the grid's doing. But also, you can think of that as the gatekeeper for what goes on, and that'll make a little more sense in a few minutes. And then, of course, batteries, storage devices, which can help provide power to your home at night when the sun's not shining, so you're still not dependent on the grid. So typically what happens, the sun's shining, your solar panels are making electricity, feeding the house, and when the sun goes down, this thing shifts over and starts draining the battery and using that to feed your house. And it'll do that as long as there's power in that battery, and we'll talk a little bit more about that. So batteries, by the way, are optional. You don't have to have a battery in your system. This is another component that's optional. You do not have to have. It's called a critical loads panel. Critical loads panel is just like your distribution panel, except it's a little side one. It's only got a few handful of circuits on it. This one here is 10, minus 10 circuits, 30 amps. And I put my critical loads on here because if the grid goes away, my solar panels and my batteries still work, and they'll provide power to this critical loads panel. And then that keeps the things that I think are important going during the outage. It's got three positions on it. It's got an off, gen, and line. Gen means coming from the solar panels, and line, you can switch it to there so it comes straight off the grid if you want.
Well, that's all manual into?
That's just, it is, and that's just set up and left alone. So what are your critical loads? You know, refrigerator, freezer. You can figure this out, you know. I have a furnace now, some of my critical loads didn't work during Snowmageddon because there was no power, even though I had a propane furnace. But I've solved that problem. You may have something important to you, maybe an Xbox or an espresso machine, you know, who knows? But you can figure out what's important to you. It's just got to be within the capacity of your system. So those we can do that. But anyway, now we're going to talk about these configurations, depending on what your objective is, how we can put these pieces and parts together to get to what you want. So let's talk about the basic system first. The main reason you want to do this is reduce your electricity bills, or maybe to reduce your carbon footprint. And I'll do several things for you. It just consists of just solar panels that control an inverter. That's it. No battery, no critical loads panel, no generator required. It's your least expensive option. And however, it offers no grid loss protection, and you can't sell your excess electricity. But it's the cheapest way to go. And this is what it looks like functionally. You have your solar panels up on your roof, and this controller is typically with the inverter all in one box. You won't have batteries in the system. So this is your DC up here. Your inverter makes AC, ties it into your switchboard, and feeds your electrical loads. When it can't do that, then the grid feeds it through your meter. If the grid goes away, this whole system shuts down, because you don't have the other necessary equipment to keep some things going. We're going to talk about that next. But this is your most basic system. It'll reduce your carbon footprint, reduce your electric bills. So next question is, do you want more from your system? Okay, some protection from grid outages. First of all, you got to add a battery and a critical loads panel, and that'll become evident here in a second. May lose non-critical loads with the loss of grid. And that's your non-critical stuff. Not necessarily, you can wire it differently, but typically think we're going to protect those critical loads. You're going to need a battery. It doesn't have to be big, however, and this is important. When the sun's not shining and the grid's not there, you're dependent on that battery or a generator. We'll talk about that in a few minutes. that battery has to be big enough to carry your loads through the night. And depending on what your loads are, you may need a pretty good sized battery. And if you expect it to carry much more than that, you may need 2 batteries or 3 batteries. And I'll tell you right now, they are expensive. And there's probably better solutions than just trying to get enough battery packs to carry you through. For example, we're going to show you some weather data later on where you can have multiple days where your solar panels are not producing much. And to have enough batteries to carry you through all that would require a lot more money than I have and a lot of space. Okay. So we'll talk about that, but you need to have at least a small battery for the system to work because you got to be able to run the electronics when the grid goes away. So you're going to need a battery. So my suggestion is if you want protection from grid outages, the best thing to do is supplement it with a generator. There's a couple ways to do that. And also with this system though, you can sell excess generation. I put maybe, depends on your electric provider, your contract terms, and again, part of your setup. But this is what it looks like from a diagram standpoint. Got your solar, this is basically what we just saw before, solar panels, charge controllers, and this. But this time we're adding some batteries, and we got that critical loads panel right here. So now what happens is on a loss of grid, this whole system down here shuts down from everything below this line. No grid, nothing goes to the meter, doesn't go through your main panel, all these appliances shut down. But these solar panels or this battery keeps this inverter going, which supplies that critical loads panel. And we'll keep doing that as long as the sun's shining or you got battery. So if you want to go even more complex, more capability, more cost, you can go off-grid operation or full loss of grid protection. This is the most complex, requires a whole house generator, which you can tie in to your that magic inverter box, and it will auto start it. There's all kinds of things. So you get this set up right. You got a whole house generator, the grid goes away, it all starts, carries things, you'll light some, flicker for a little bit maybe, and you'll just keep going as long as you got fuel for your generator. Does require battery. Again, it doesn't have to be huge. But you want a generator that's big enough to carry your house loads. And this is what that system looks like. Again, solar panels, your controller, batteries, here's your generator tied in. So what happens is when this guy senses that the grid's gone away, it'll auto start, it'll isolate over here, take the grid away, start that generator, and between the generator and your batteries, it'll keep everything going. You can do it either just with a critical loads panel or a big enough generator, you can feed the house. The thing to keep in mind is whatever we're doing up here with the grid down, the grid has to be isolated, and this does not show that. But this box up here monitors what's going on in the grid, and depending on your configuration, there's maybe a switch or something needs to be added here. But you cannot be putting power over here with the grid down because all that voltage goes out on the grid, and now we can hurt somebody with Encore servicemen. So Encore is going to make sure that in the grid outage, you are isolated and cannot impact the grid. So what do I have? I have 41 panels, 40 of them installed, 1 spare. They're 435 watts each for a grand total of 17.4 kW. And they are reconditioned less than 2-year-old. They're not brand new. That's what I had installed. Got a price break on it. I have a battery, which is 19 kilowatt hours. So basically 50-volt battery. It's a lithium iron phosphate battery. It's yay big. Same kind of battery that you have on your EV, your electric vehicle. And mine is 19 kilowatt hours. Okay. to put that in perspective, my Mustang Mach-E, which is sitting out here, has 131 kilowatt hour battery in it. Okay, just so you know, comparisons here. It has a 15 kW converter, inverter. I've got a critical loads panel with 10 circuits, 30 amps, and then some fancy electronic monitoring systems, which if you're a techie, you get all kinds of data. I can monitor it on my phone, away from home, on the internet, whatever. I can see what's going on. It gives me warnings if the grid's gone off. It's a pretty sophisticated system. This is what it looks like in the garage. With the battery here, there's that solar panel and some monitoring systems connected to the internet. And I'm going to show you what close up of this guy right here. Of course, solar panels are up on the roof. So that's what that looks like. And it gives you a status of what's going on. And you can see here's kind of the four big things going on with the system. One is the solar panels, and that's at this point in time, I don't think I put the date on it, but typical afternoon, it was generating 10.3 kilowatts. And of that 10.3 kilowatts coming in from the solar panels, about 3 kilowatts are going back to recharge that battery, 6 kilowatts to feed the house loads, probably air conditioner and a few other things going on there. And I had some excess left over to the tune of about 1 kilowatt. It was feed it out on the grid. So typical setup. Now, in the event of an outage, of a grid outage, if this goes away, then this will provide, they'll send it to my critical loads panel, which you'll see it here. And if there's any excess, it'll charge the battery. If it's not making enough for the critical loads panel, then it'll start draining that battery to feed it. So that's how the system is set up. How's it work in the real world? So here's an example electric bill from July of this year. And the way the system was set up is got so many kilowatts that the meter sees coming in, and I have so many kilowatts that I've sent out. And it looks to see what I sent out, and it'll offset the cost of what's coming in up to a point. There's still encore carrying charges, but that's what we're going to show here. So in July, I pulled 413 kilowatt hours in from the grid. I was being charged 14.4 cents. So I had a $59 electric bill, but I actually generated more than I pulled off the grid and had excess generation in excess of that. But it'll only credit me up to what I used. So 413 kilowatt hours excess to the grid, which offset that electric bill. So between that and that is zero. But Encore charges me 4.4 cents an hour for those kilowatts that I bring in. And that only makes sense. And I don't mind paying that because they're the ones that are paying for all the transmission lines, the distribution system. I want to stay connected to the grid. So when I pull power off that grid, I should expect to pay those Encore charges. So I don't mind paying that. $20.12. I had a $10 a month service charge for a bill of $30.12. So diving in there a little deeper. So here's my production data. My solar panels for that first year generated 23 megawatt hours or 23,000 kilowatt hours. During that time period, I also pulled 3.7 megawatt hours in off the grid. Of all that power generated, how did it get used? 15.3 megawatt hours got used to power up the house, charging the electric vehicle, whatever, all those loads. I had excess generation to the tune of 10.7 megawatt hours went out on the grid. So what does that mean? Well, that means I'm averaging about 64 kilowatt hours every day on average throughout the year of solar generation. I'm consuming about 42 kilowatt hours every day on average. Excesses go into the grid. Now, your usage may be a little bit higher than that. I don't have a huge house, but what I also have is propane hot water heaters and a propane stovetop. I also have a propane backup furnace. I've got 2 heat pumps that take care of the house, but when it gets really, really cold, the heat pumps don't keep up, then that propane fire furnace kicks in. So my setup may be different from yours, so you have to kind of look at your own setup. So if you're from Encore looking at what's going on, there's that 10.7 megawatt hours going out to the grid, and the 3.7 came in. So my net excess generation for that first year was almost 7 megawatt hours. And that was used to offset my electric bill, but I didn't get any payback for all that excess generation. That was the first year contract terms. So if you look at my electric bills, I pay $372 for electricity, $10 a month service charge, for a grand total of $492 or $41 a month is what my electric bill was for the year, including that $10 a month service charge. So after the end of the first year, I contacted my electricity provider, tell them I don't like what's going on. I said, I gave you guys almost 7 megawatt hours free electricity. And what am I getting for it? Nothing, basically. They said, well, we have a deal for you. So I have a new contract that just went in effect after the end of July. And the deal is, first of all, the cost of electricity has gone down from when I had that contract a little over a year ago. So I'm paying a little bit less for the electricity that I do use. It's 10.7 cents per kilowatt hour instead of 14.4. Then on top of that, for any excess generation, they're paying me 4.2 cents a kilowatt hour. So we'll have to see how that works out for this next year. But I went back and calculated if I'd been under that contract, what that first year would have looked like. And that's what I'm showing you right here. So one of this new contract, taking last year's data. So there's that 3.7 megawatt hours in from the provider, now at 10.7 cents per kilowatt hour, or $399 charged for the electricity brought in. There's the Encore charge that goes along with it. There's that service charge of $10 a month, but I sold back 10.7 megawatt hours. I would have sold back that much to the grid at 4.2 cents, which would have reduced it that much. Net $235 for the year, basically $20 a month. That's this year looks just like last year, then I should be averaging about $20 a month electric bill. So this is one of those things too. I can reduce, one of the ways to reduce that usage right here, try to get this Encore number down, is if I had more battery capacity. Well, you saw the numbers on the battery. It was a 13 kilowatt hour or 19 kilowatt hour battery. We're talking almost $10,000 to buy one of those. So it doesn't not make a lot of sense to spend a fortune on batteries just to offset those kind of costs. Thought I'd show you this one because this one I'm particularly proud of. This was April the 27th, 2023 at 1:41 p.m. in the afternoon. Sun right overhead, clear sky. And my 15 kW system was, let's get that up here, was generating almost 18 kilowatts. Okay. Beautiful day. 18 kilowatts I was generating. Of that, 3.8 going back to recharge that battery. 12 kilowatts going into the house. You go, what on earth is going on here? I was charging my car. Okay, and one of the things I want to impress on you, I've got another slide to show you, is that the charge rates for electric vehicles will take your breath away. Okay, and I still had some excess generation left over, even with that, and 1.5 kilowatts is going out on the grid. But this is one of those things I do, playing around, trying to manage when I'm charging the car, when it's producing the most electricity, so that I'm not having to pull it off the grid. Okay, so with that as background, if you're thinking about doing this, one thing you gotta do is size your system. So how do you go about doing that? Well, I recommend a couple things. First of all, look at your electricity bills. They'll tell you how much you're using, and it changes significantly month to month. Spring and fall typically a lot less. Summer and winter are your biggest bills, and you know that because of electricity and heating bills. Then you also need to factor in seasonal efficiency of your solar system. I'm going to show you about that, some of that. Anticipate any future load changes. Are you thinking about buying an electric vehicle? If so, you may want to include that in your capacity. Also, if you're doing any kind of electric conversions, for example, I've got 2 propane-fired hot water heaters. There are incentives out there right now to get rid of your gas hot water heaters and install electric. And I don't quote me on this, but it's like you get a federal incentive of somewhere around $600 or $700 for a hot water heater. You might be considering house modifications, increasing whatever. So all these things you need to think about when you want to size your system. Also, what kind of real estate available do you have for panels, roof space or whatever. So when you do that, you'll start looking at your typical loads, and you can look this up anywhere. I mean, it's pretty standard. If you got a 1,000-watt microwave, that's basically 1 kilowatt. Dryers tend to run pretty high, around 5. Air conditioners, depending on the size, anywhere from 1.5 to 6 kW. But you can look at that stuff. Refrigerators don't pull much. Freezers don't pull much. But this is what I want to show you about electric vehicles. I have a full 240-volt charger, which I use to charge my vehicle. I can set the charge rate, so it's not like plug it in and it's full bore. I can set the charge rate. But if you look at this at 48 amps, which is my max charge rate, that's almost 12 kilowatts. So that's 12 kilowatts continuous while it's charging. And if you've got an EV that's down at Parade Rest and you want to get it up close to 100%, that may take you 10 hours. So that's a lot it will be your biggest electric load by far, twice or 3 times bigger than anything else you got in your house when you turn on those chargers. So just one of those things to keep in mind. Okay, so when you're sizing your system, the other things you need to think about is solar panel efficiency. First of all, where's it going to be oriented? Okay, south is best, then west, then east, and then north is worst. Okay, and that's just, is it going to be pointed at the sun? It's as simple as that. Roof angle, the flatter the better. I'm pretty fortunate. I got a real flat roof. Not in my house, I have to have a hangar, and the hangar's got a very flat roof, and that's where it sits. So the roof angle is to my advantage. Trees, and obviously anything's going to cast shade on it. And then there's our old friend weather. And I mainly put this up here is just because you've got a 17 kW system doesn't mean you're going to get 17 kW out at all time. When the weather comes, cloud cover, it goes, production plummets. Okay. Also, the declination. We're going to talk about that a little more specifically. In other words, the angle of the sun. And this is a little busy, but this just shows you what kind of sun to expect depending on where you are on the planet. So if you are on the equator, and you can see throughout the year, this is from January to December. Throughout the year, you got pretty consistent sun exposure. It's going to change a little bit during the March. The equinoxes, you get a little more exposure, a little higher because that's when it's right over the sun's right over the equator. And the solstice in June, and the winter solstice, which is on the edges here, that can change things. So here we are, we're near this green line. So starting in January, you can see as the sun moves north in the sky, it peaks here in June at the summer solstice, and then decreases during the winter solstice. But that's where we sit. The point being, you get a lot more solar production here than you get here. Okay. Just be glad you're not on the North Pole, because if you're on the North Pole, you can see they get nothing for 6 months of the year. And then they get a lot all at once because they get 24 hours of sun. Okay, but you don't want to live there. But this is where we are. But you have to factor that in when you're thinking about sizing your system. And here's typically what it looks like throughout the year. This is a 1 month shot in production. You can see there it is, the winter solstice, this summer solstice, and it follows that pattern. Okay, it's not perfect because there's some weather involved here, but you get that idea. I'm going to show you this particular one. I know it's busy, but you don't need to read it, okay? This is February of this year. I'm sorry, it's now last year, February 2023. I'm only showing February. I'd like to have got January backed up in here, but I just couldn't get it, couldn't wing it. But you'll notice there's almost no generation. This is generation for each day in February. There's almost nothing here, very little here. This is what happens in a month, particularly in the winter. You'll have good days and you have some bad days. Cloud cover. Okay. If you remember, at end of January into February, we had about 5 days where the weather was horrible. I mean, there was cloudy, dense overcast day after day after day. That's from January the 29th to February the 2nd. During that 5 days, my total solar generation was 31 kilowatt hours. Okay, I'm typically making 65 on any 1 day average. 5 days, total generation was 31 kilowatt hours, or about 6 kilowatt hours per day. 2 of those days was less than 2 kilowatt hours. You'd have to fill up your garage with batteries if you think you're going to overcome that. Okay, so if you're trying to be off grid or protect yourself from lengthy outages like that, you're going to have a generator because it's just too much. Well, yes.
Dave, during the winter months, how much would it help you though to be able to adjust your solar panels so you were facing more directly towards the sun?
It'll help if you can move, but now you're a movable system,
A lot more expensive.
which is expensive, but that's what the commercial ones do. They have sun trackers on them, so they'll tilt the whole array. I don't know how much it costs to add that, but they're fixed up there right now in position, and they'll put them on a motor and move them will help a little bit, but I'm not sure how much. So that's some things to think about when you're sizing your system. Okay, now we're going to talk about costs. So I just pulled this off the internet. You can look, but typical system size from 5 kW up to 10 kW. Remember, mine's 17, but mine is deliberately high and more than what you need. And you can see it runs about $25,000 for the big one, but you get a 30% investment tax credit. And you remove after that, you can see the cost is a lot more reasonable. So estimates can vary quite a bit. Prices change. Incentives and tax credits can affect your bottom line. So if you're thinking about doing this, I get several bids. I just read an article in Forbes that said the average cost for installation of solar system last year was $18,000. Okay. And that's, I can assure you, is smaller than mine and a lot basic, most of them are pretty basic systems. As I mentioned about batteries, here's two batteries. This one here is similar to the one that I have. And this is the Tesla Powerwall 2. I think they're coming out with Powerwall 3 now. The one that I have, 18.5 kilowatt hours. It's about 10. This one here is $10,000. One on the left. The Tesla Powerwall 2 is cheaper at $8,100, but it's only 13.5 kilowatt hours. So what does that mean? Let's say you've got a 3 kilowatt heat pump like I have in my house. And that means with my battery at 18 kilowatt hours, I can run that thing continuously for about 6 hours and it's dead. On the Tesla, you can run it for a little bit over 4 hours and the battery's dead. So again, that's just a data point to keep in mind in terms of battery size, capacity, what can it really do? Now, most heat pumps don't run continuously, they're off and on, but that'll kind of give you an idea. You run a heat pump and you turn on your stove and you got a refrigerator and a freezer and you got your computer and your television, see it all stuff adds up. So I told you about my system. I'll tell you what it costs. So here's my system. We went over this. We've got the solar panels, this battery, the inverter, critical loads panel, and the monitoring system. $48,500 to install it. I got a 30% investment tax credit, net $34,000. Again, my system is bigger than most. For my purposes, one, I wanted to be able to charge my electric vehicle. Two, I wanted to offset as much as I could my carbon footprint. I still have an F-250 pickup, which I need to pull a camper that runs on diesel. And I have an airplane, so I'm trying to offset the use of it too. The good news is I haven't bought gasoline in over a year. So, but you don't have to buy a system. There are other options. You can lease them. So we could talk about that. So here's some buy versus lease decisions. So if you're going to buy it, kind of background, if you're going to buy it, you got a couple choices. You write a check, you can finance it, or you can get a home interest loan. So your best bet's just write a check. You'll get your payback best, and you're not paying any interest. Short of that, get a home interest loan if you can do that. Because if you get a home interest loan, you're adding something to the house that adds value to the house, becomes part of the permanent structure that is embedded in the value of the home. So you can get a home interest loan to cover the cost of it, and the interest payments on that loan are deductible if you're itemizing your income taxes. If you just get a commercial loan, like a solar installation loan to install, that's another way to do it. Typically, the interest rates are going to be higher, and you cannot take an investment tax credit. Excuse me, you cannot use the interest on it as a deduction on your income tax. Okay, you still get the investment tax credit if you're buying. Leasing it is the other option. And that's basically where somebody else owns the system. They're going to come in and install it. You may have a small down payment, and then you're going to have a monthly payment to lease it. And a big sales incentive there is what you're paying them is likely going to be less than what you're currently paying for your electric bill. And that's why a lot of people go leasing, because there's zero upfront or very little upfront dollars. No, but there's pros and cons to that. That's the two ways. So let's look at this. If you buy, typically you're going to have a high upfront cost, particularly if you write a check for it, or at least a down payment if you get it on your home equity loan. The good news is you own it. It's yours. You get an investment tax credit, and any incentives are eligible. Payback's typically about 7 to 10 years. So if you don't have an MBA, somebody's asking me about, does this make a good investment? I said, you can do better than that. But there's other benefits, and we'll talk about that, why we do these. Interest may be deductible, as I mentioned, if you get a home equity loan, and it adds to the house value. We'll talk about that more in a second. If you lease it, low upfront costs, but the company that installs it owns it. They're going to own your roof. No incentives or tax credits. Because it's not part of your house, it's just something you're borrowing. Modest savings is what's shown over the years. Because you're paying the cost of the lease. Right? And any interest on it. Home sale challenges. Okay, you decide to sell your home, you got this 20-year lease on solar panels on your roof that you don't own. You got two choices. Somebody wants to buy your house, encourage them to take over the lease. Or you're gonna have to buy out that lease and have them pick the panels off. And sometimes there's a extra fee for canceling your lease. I read this one where somebody had $16,000 was left on what they owed on the lease payments, but there was a $21,000 lease cancellation fee or something like that. So anyway, that's just something to be thinking about. The other thing, there's no value added to your sales price. You got my solar panels add value to the house from a real estate standpoint. But if you don't own them and they're leased, they don't. So it's just that's the other thing to think about.
Does the 7 to 2 year payback take into account that you're saving on your EV?
No.
That would be a bit faster.
Exactly. There's some additional savings there.
Does insurance cover your solar installation? Your house insurance?
Yes, and for those of you that are on Zoom, the first question was, does the use of use in an EV, is that calculated in the payback period? And the answer is no, it is not. So the payback period could be shorter. And then the other question is, does insurance cover your solar panels? And the answer is typically yes. If you get solar panels installed, you can make sure to let your insurance company know that they're there. Typically it has no impact on your cost, but they need to know about it. And yes, they typically cover it. So here's some other considerations. First of all, homeowners association. A lot of times they have rules that can impact what you can do. But some things to know. In the state of Texas, homeowners associations are prohibited from restricting rooftop panels, even facing front. They can't tell you that the homeowner associations can't not tell you that you can't put solar panels in. Another thing is that Texas constitutional amendment gives property tax exemption on those solar panels. Although it's increasing the value of my house, the taxman can't add that to my tax rate. So that's another good thing. Home valuation for resale considerations. 2/3 of home buyers consider energy efficiency very important in their decisions to buy a house. So if you got solar panels, this is going to be a plus. You have to own them, as I mentioned, if not leased, adds to the valuation. Then the other considerations, you got to talk to Encore, or whoever's installing it will talk to Encore. But again, we got a couple things that they're interested in. Are you going to be putting power out on the grid? If so, they got to reprogram your meter. The other thing that they're interested in is protection of their workers, so that you cannot put power on that grid when the grid's down and their workers are out there trying to fix something. That's their main consideration. And your installer knows how to deal with all of this. And then, of course, your supplier, whoever your electricity supplier is, may have some additional. Yes,
Have you talked to Bill Cove?
I haven't.
Okay.
Yeah.
The Bill Cove doesn't want it. You can't, if the grid's down, you're down.
We heard that the same thing, that it's illegal to have your solar panels work.
Right.
Yeah, and that's not true. Now, I don't know what's going on with them. But there are isolation devices within these systems to isolate you from the grid.
Yeah,
So my solar panels provide power to my house when the grid goes out. And I've demonstrated it. And it's not illegal. And that's Encore. I'm not sure. You're talking electricity provider, but if you live anywhere in this part of Texas, Encore is the distribution system. And they're the ones that make the rules. And as long as you can, your system can provide isolation, then it's gonna be down. But remember, I told you that very first low-cost solar installation, we just got panels to offset your cost, doesn't give any grid isolation. So when the grid goes down, it goes down too. Okay, I have neighbors that have solar panels, and when power's out, grid's out, they're down. Even though they got 15 kW where the solar panel's sitting there. My system isolates from the grid. I power up my critical loads panel. It is not connected to the grid through my main distribution panel. So there are ways to do it.
So when you power yourself up, you have to manually go and flip the switches, right?
I
It's
do
not
nothing.
automatic. You do nothing.
I
It's
do
automatic.
nothing. It's because that critical loads panel is powered from my system, not from the grid.
Okay. So
Maybe
transfer
your
switches
owner
off.
allows it, but then our supplier might not.
Your supplier may have different, that's a whole nother ballgame, okay? So if you're in a co-op, you gotta go by the co-op rules. If you can choose your power, you don't like your answer, go pick somebody else, okay? That's the benefit of doing that. But if you're within a co-op or municipality, you're stuck with them. So my recommendation is if you are one of those customers, then you get a hold of the board of directors and you start chewing on their ears saying, why are you not doing things? Why you have a system that, why don't we have this benefit that other providers have? Why are we not promoting, trying to reduce our carbon footprint? So I'd get after them because the board of directors runs decides what happens within that company. Okay, but what are the benefits, okay? Let's talk about this. Reduce electricity bills for obvious reasons. Tons of data. I'll show you a couple things too, just in case you're interested. But if you're techie like me, it gives me more data than I can handle. Increased market value for your house, assuming you're not leasing them. We talked about charging your electric vehicle. And that's something I have to be, takes a lot of manual intervention. Because when I plug it in, it starts charging. I can tell my charger to only charge during certain hours. And so when I plug it in, it'll actually, unless I need to override it, it'll only charge from like this time of year between 10 a.m. and 4 p.m., assuming the sun's out and I've got solar panels. But it doesn't know if the clouds are there or not. So there's some manual intervention on my part that I sometimes will go out and unplug it because we're not making enough electricity and my wife wants to run a dryer or something. So there's some manual intervention, and that's just because I'm a cheapskate. I'm trying to avoid those Encore charges, okay? And it's just fun, this is one of those things you can try to game the system a little bit. Of course, carbon footprint reduction, and associated with that, it's hard to figure. So this isn't exact, but carbon footprint reduction is how much carbon we offset. Well, if we're not using solar panels, then it's coming off the grid. Well, what's powering the grid? If it's all wind and solar, then we're not offsetting anything. But typically in Texas, there's a lot of fossil fuels. You got coal-fired plants and you got natural gas-fired plants. So I'm offsetting there. But if you look at a national average, what powers up your grid, you come up with this number here, 0.855 pounds of CO2 per kilowatt hour. And based on that, my first year's production, I've avoided almost 9 tons of carbon dioxide. And then on top of that, question about electric vehicle charging. First year, 6,500 miles, no gas purchase. I charge them with the panels. I've only like 2 or 3 times I've actually charged it outside the house. As an experiment, I'm part of it. But if you just look at miles per gallon, all that stuff, I probably saved about $680 in avoided gasoline purchase. This is one of those many reports I get. And what I wanted to point out here, now this says as of the end of November, so this is a little bit more than a year, but this was the lifetime energy production of my panels. I'm up to almost 30, over 30, well, now over 33,000 kilowatt hours. But this is what I want to point out. That's equivalent to carbon sequestered by 28 acres of forest in 1 year, or the greenhouse gas emissions saved from 5 passenger vehicles driven in 1 year. Okay, that's how much the impact on our carbon footprint. And then I want to show you this, just a techie data thing. And I know this is very difficult to read, but I'm just going to walk you through it. You just need to see kind of in general what I'm referring to. But this is what a typical day looks like from midnight to midnight. And you can see throughout the night, this little red is my load. And there's an air conditioner coming on and then off, air conditioner coming on and then off, air conditioner coming on and off. And you can see that through the evening. So through the evening, this is my battery charge starting at midnight, and the battery charge is going down and down and down as it's carrying this load until here when the sun comes up. Now this is in October, so my battery carries me all through the night. Does that very often in the spring and the fall, does not do that in summer and winter. So here the sun comes out and I start making solar production. That's this green line right here. And as you expect to get this nice big round peak, we'll talk about that in a second. So what happens is first it starts carrying the loads and then it starts charging the battery. So the state of charge in the battery goes all the way up till it reaches 100%, and then it just stays there until the sun goes down and I start draining the battery again. So this is the battery discharging during the night, charging during the day, discharging at night. This is my house loads, and you can see this load here. This is kind of what your kind of base load. That's your vampires. Okay, that's your key form systems on your televisions, little digital clocks that are everywhere, security system, the computer, your Wi-Fi, all that stuff sucks up a lot of energy to the tune of like 500 or 600 watts all the time, even when all the lights are off and you think things are not running. The grid is yellow. So you can see I'm not pulling anything off the grid because the battery's supplying it. And all of a sudden I go boom, down. Well, that's because I'm making electricity I'm not using. I'm actually feeding the grid right here. So all the stuff with this yellow down here is me selling electricity to the grid. And then there's my production. Here's my PV, your solar cells, and it's green. So it's obviously not going to do anything until the sun starts coming up right here. And it goes up and down, up, and then down. This was a cloudless day. Okay, so you would expect it to be perfect up and down. It was October the 14th, 2023. What happened right here?
I heard it.
What
So,
little,
the solar
that was the solar eclipse.
The solar eclipse.
Okay, isn't that cool? I thought that, man, look at that. The solar eclipse comes and there's my solar panels. Okay. Isn't that cool? So, April the 8th this year, we'll see the same thing happen with our solar eclipse. So, I got a couple references you might be interested in, and then, finish up here in just a second. So here's some references. You know, Texas Controller Public Accounts, they got a publication that talks about, you know, energy and solar and stuff. This is the DSIRE, the Database of State Incentives for Renewables and Efficiency. This is a compendium of all the incentives and things that are out there. Of course, the DOE's got this nice little homeowner's guide to going solar. So if you want a little bit more than what I told you, you can go to that, and it's a great little, relatively short guide to help you guide you through solar systems. And of course, for those of you that get to pick your own electricity provider, I'm hoping you're familiar with powertochoose.org. So you can get a lot of data and find out companies that will work with you with your solar panels. Next thing I just want to mention is, our next ANC lecture is going to be in, this is a quarterly deal, so in 3 months, April the 7th at 2 p.m. Gary Hines, one of our other fellow master naturalists, is going to talk about the solar eclipse, which is going to occur on April the 8th at 1:30 in the afternoon. Okay. And then with that, let's see if anybody has any further questions.
I've got a couple of days.
Okay,
Yeah, Robert?
Yeah, I was just curious, I may have missed it, but is there a life expectancy on both the solar panels and the battery? And what happens to them once they reach that point?
Okay, solar panels typically have about a 20 to 25-year life. After that, I think typically what happens, they don't have their rated efficiency anymore. My gut feel is that you could probably use them for considerably longer, but for planning purposes, you got to think about having to replace them by then. Batteries, on the other hand, are kind of cycle limited, as you might think. So they're rated for, I think mine's like 10,000 cycles or something. And again, like most batteries, once you get past a certain cycle limit, you may not get as many kilowatt hours out of it as the nameplate says, but eventually they'll become less useful.
We have a question on chat that wants to know the dimension of the inverter / controller.
Okay, I don't have the exact dimensions on it, but it's roughly 2 feet by 4 feet by 1.5 feet deep. It's not big.
Dave,
Yes.
Bob Walker's question, what happens to the panels and the battery after they're obsolete?
The question is, what happens to the batteries and the panels after they're obsolete? Right now, there's not a good way to recycle all the components on solar panels that I'm aware of. But we suspect with so many of them being made, if there's any kind of economic reason to recycle them, somebody's going to figure that out. Where half the roofs in my neighborhood got replaced from a hailstorm this spring, the solar panels could care less. There are hailstones big enough to crack a solar panel, but
With that,
they do better than other people's roofs.
so when a panel goes out for a thing, you got an array and they're all 200-watt panels, right? You got to replace 2 or 3 to keep the series going,
No, I think they can just replace one of them.
and that's it.
Yeah,
You don't have
because
to replace the whole unit because you've lost.
no,
They're
this
not
would.
equivalent anymore as far as specs and all that.
Yeah, and the reason is, let's say you got one that all of my, the ones that are up there right now crank out 47 volts, full. And you got one now that'll crank out 53. It doesn't care because it puts this all in series. And this MPPT controller, I've got 3 different strings. All 3 of them are making different peak voltages. And it combines those and figures out a way to make all that magic work. So as long as the output of a string is between like 300 and 450 volts, it doesn't care.
So the controller controls all that.
The controller takes care
And
of it.
that controller, will it let you know which panel goes bad?
Absolutely,
It
because
will.
I get that TGO report on there. I just showed you how many, acres of stuff. We looked at the top of it, it gave me a report on every one of those 40 solar panels.
That way you can find out.
Yeah, I just instantly look at them, they're all green. Mine are all green, they're color coded. And you can instantly find out if there's a
Yeah,
problem.
I think the same thing if you have a number of batteries, will it read which ones go?
Oh,
bad?
absolutely, because batteries have all these new batteries have a battery management system in it. Some of that's partly to protect the battery, but also to protect your home. These are the same lithium iron phosphate batteries that catch fire, okay? It occurs when they get too hot. 160 degrees Fahrenheit or above, it's chances go up for these batteries to get hot. So these battery management systems, they monitor what's going on. Each one of the cells, the temperature of the unit, it starts getting too warm, it just says, I'm not playing anymore, shuts itself down. So there's a lot of protections built into them.
On your panel array, if you got one that's getting shade, does it shut the system down or just that one panel's not being?
It's just not working at peak efficiency. It it has no effect on the string.
Okay, how
Yeah.
much do the reconditioned panels save you?
I don't, honestly, I don't know the answer to that. The question was how much the reconditioned panel saved me, and I don't know the answer.
Are they difficult to find? You have to know somebody?
Yeah, well, the guy that installed my system got a lead on a bunch of them. And, I don't know how hard that is. Yes,
How much performance variance is there on renewable output based on temperature? How much do they put out in middle of July, sunny day
right.
versus January, sunny day?
Yeah, the temperature effects on the panels is not significant.
Real world? it
Real
just
world,
doesn't-
there's not
amount
significant.
to much.
No, it's much more impactful on that, where the sun is. And I remember reading about the temperature effects. If they get real warm, their efficiency goes down a little bit, but it wasn't much. It was like 1% or 2% at the most.
They give you a figure based on each degree Celsius that the surface temperature of the panel goes up.
Right,
But it's hard to tell if. It's hard to tell how meaningful that really is, because if you carry that out, it's like it's 20%, but I don't think they really lose 20% of their.
I haven't
efficiency.
noticed it. Even those 108-degree days, I could not tell anything significant. It might have been off a few percent, but I couldn't tell looking
A
at
few
what
percent is nothing.
Yeah,
20% is.
yeah, I would notice that.
Yeah, so, okay.
Yes.
On the shorter days versus the longer days, is it able to take care of the needs for the nighttime?
It does, it's, the question is, does shorter days versus the longer days, does it take care of what the real driver is what loads are going on. And it handles it through the night in the spring and fall, even though those are not the longest days. You know, the longest day is June 21st. But the problem is you start getting into late June, starting to get into June, July, August, and your air conditioners are running all the time. So, and I've got 3 air conditioners in my house, 3 heat pumps, and one of them's usually not running. But you know, when it's hot out, those boogers just run and run and run, and that's what drives it in the summer. And then in the winter, they're heat pumps, the same thing. So it's really outside air temperature is what drives whether the battery can handle it through the night or not. What loads you got going? Yes.
Do you know of, or do you know if the data that you have is based on a study that takes into account, in the carbon footprint, the entire system providing that power? Or do you know of a study that gives you information on it?
I think you're talking about what's the carbon footprint in manufacturing, all the components and things like that. Is that what you're asking? Yeah, I don't know the answer to that. And it's so hard because there are some facilities the manufacturing facilities are going to zero carbon footprint. And so they're using renewable energy to make things. And there's others that are using a coal plant next door, you know, and it could be horrible. I just don't, it's hard to find the data. I couldn't even tell you where these panels are made, you know, they could be Chinese or somewhere. I just honestly don't know. But the good news is we're ramping up our production capability in the United States. There's a lot of incentives for battery manufacturing, so much so that the investment tax credits on an electric vehicle are going to be contingent upon where the batteries are made, and some other things to encourage that to happen in this country, which we really need. Yeah, Malia?
Do you know how quickly technology is changing that's going to make the current technology, you know, less efficient or obsolete in 5 years?
They're working on higher efficiency solar panels, which may get up to 25% or so. But you know, and this is just my opinion. This is basic nuts and bolts electricity stuff, you know, there's only so much efficiency you can get out of inverters, electronic equipment. If you can get solar panel efficiency up, that'll help. But I don't, in this business, I don't see any game changers, you know, we want to talk about small portable nuclear power plants, that's a whole nother issue, but, you know,
Thank you.
any other questions?
Who are your main opponents to solar energy? Encore or the individual carriers,
What was
the companies?
What was the question again?
What, who is more opposed to solar energy?
Opposed? I don't think either one of them.
Okay,
The Encore is more willing to work with you. They're interested in, do you have the right meter? And how to protect their people so that their system is, your solar system can be isolated from the grid in the event of a grid outage. So I haven't seen any problems with them, and the retail electric providers, if I don't like who we deal with, I'll just get a hold of somebody else.